Hello, welcome back to the course on audio signal processing for music applications. This week we are talking about sound and music description, and in particular we are talking about how to analyze sounds in order to then be able to describe them within sound collections, so that we can compare sounds, we can classify, we can cluster sounds and describe in that way collections of sounds. Therefore, we need access to collections of sounds from a software type of perspective. So we need to be able to access these sounds programmatically and then obtain these analysis results and play around with them. The Freesound API, that's an excellent tool for doing that. So Freesound has a lot of sounds, and through the API we can, using Python for example, we can access all the information within Freesound and then process it in many different ways. So let's try that. So let's go first to the Freesound website. Okay, and in order to learn how to use the API, we can go to the developer section down here. Okay, and here it tells me a little bit about the API. So first of all, what's an API? Well, an API is basically it's a protocol, and in the case of web APIs, is a protocol that uses the HTTP protocol, and we can make calls, HTTP calls, to Freesound in a way to query the specific content of what is in the database. So we don't have to use the web type of interface to access that. Okay, and in the documentation there is information about how to actually do that. Okay, so there is information about how to access the different sources of information. So if we go to the resources page, here it tells me how to search the different content types. So for example, here in the search resources, it starts by talking about a text search. So we can query, and we can do the standard text query that Freesound has, but programmatically, and we can apply filters, and we have basically access to all the information that has a text label inside Freesound. But we can do a lot more than that, and we can also search for the content. So we can search, for example, to the analysis data, these low-level features, and then not only just get them but filter them. So for example, here there is an example of how to get the pitch of the mean of the pitch of a sound that is 220 hertz. Okay, so you will find sounds whose mean pitch is 220 hertz. So that's pretty good. It can be quite powerful to do that. To get a visualization of that, we can go here. This is a specific call of the API. Strictly speaking, is not a call to the API because we are not using kind of a software to make this call, but it's an option to have a URL that displays the information of one of the resources of the API. So if we specify the Freesound website and then follow by API version 2, so API v2, which is the API version that we are using, and then specify the name sound and the number of the sound. Every sound in Freesound has an ID, a number. Okay, and it returns the information of this resource, which basically has a summary of all the information of that particular sound. So in here we see some specific examples of API calls that return more specific information, but then the default information is the one here. So this is the actual call of the API that we are now doing, and in here is the information that is returned. So we have, for example, the core information of the sound, its ID, its URL, the name of the file, the tags that the user specified, the description of the sound, etc. A whole bunch of things, when it was created, the license, the bit rate, the bit depth, duration, and also things like previews. So we have access through the API so some like low quality or high quality previews, or the images, the display images that are shown in Freesound. So that's a very good information that, of course, we can get it all together, or we can just through the API ask for some specific items of this information. And then there are things like also the analysis information, or the sounds that are similar to this one. So we can also access that through the API. So for example, let's click at the analysis statistics. Okay. So this returns the low-level descriptors that have been analyzed, the statistics of them. So we see here the different statistics for spectral complexity, etc. All the descriptions. So it's a pretty big list of all the low-level features. And again, these can be accessed directly from the API and access specific items for that. So that's pretty good. So now let's go into the resources, and we can then talk about the client libraries. So the client libraries are the libraries that have been written in a particular language, through which then we have access to this API, and we have some code that facilitates these API calls. So let's go to this Python library. Okay, so this is the library that has been written in Python to access the API. Okay, so it's a simple library. Basically, it has two major files. One is this freesound.py that specifies a series of classes of functions through which we can do all these queries through the API. So we can do the text search queries, or we can get sounds, or do combined search, or of different things. And then there is another file that is quite useful, which is the examples file. So in these examples, we have some example pieces of code that perform different things. So for example, they can perform, we request a sound, for example, here, and then we can just display the information about the sound, or we can get the analysis data, etc., etc. Anyway, so let's use it. So in order to use it, the first thing we will have to do is basically clone it. So we would just go here and get this HTTPS URL, and then do from our computer git clone this, and we will get it. But in order to use the API, we need to have an API key. Okay, so the first thing we need to do is go to Freesound and apply. So this is again the developers page of Freesound, and we need to apply for a key. Okay, that's a key that is specific to us and specific to our computer, and therefore it should be personal. So now I apply for a key, and I will delete it after I do this demonstration. But basically, let's just use this key in this lecture to exemplify how to use it. But you should apply for your own key and then use it. And then you have this API key, which it's It should be secret, and you would use it. Okay, so let's go to a text editor in which I copied the files that this client library had. It had this Freesound .py file with all these functions that allow us to call the API, and then it has these examples file in which we can do a number of calls to the API to put them as an examples. And there was a place in which I have to put the API key. So in cset token, if we go to the where we started before, in here and in the examples, in the original file, in the examples files, this is where I had to type the API key, and so if we go back to our text editor, yeah, here is where I place the API key. Now in this example code, what I do is I get one instance of this Freesound client. This again is a object that I create, is an instance of an object, is a class. So this Freesound client, and then I have the variable C. And now from this instance, I can ask specific queries to the API. So for example, I can get a given sound with a given ID, and this will return the sound. In fact, is also again an object, and then I can query this object and, for example, obtain the low-level analysis parameters and then print some of them. Or I can ask for similar sounds, so I can get the list of the most similar sounds based on these descriptors to this one. And I can do other type of queries to this basic function. So for example, instead of asking for a sound, I can do a query of a text query with some filters, and this will return these results. And also I can do other types of queries based on, for example, the content. I can search for all the sounds that have a particular range of a given low level descriptor. For example, here a given variance of a pitch or a given salience, etc. So let's in fact run this. Let's go to terminal, and I am in the directory where I have these files, and I can just run examples dot py. Well, there's not py. Run examples. Okay, and this is all the result. Well, it's pretty long, so we are not going to be able to go through everything, but the result of the examples, it gives me the sound info, and that's the first print statements that we had. Then it gives me the analysis, the MFCCs that I ask. It gives me similar sounds, the names of those similar sounds. Or then when I have this example of searching for the word violoncello, it gives me the names of different files. And then again, that other search that is in here that finds specific queries to low-level descriptors, etc. And this last one is about the sounds of a particular user, and do something with that. Okay, so that's pretty good. So let's now go to one example that we are going to build. So this is some code that in fact we wrote for the assignment of this week, to facilitate you to play around with the Freesound API. So in this piece of code, what we are doing is facilitating the downloading of a collection of sounds based on some specific query. So we defined taking this Freesound code from this client library. We are putting together a function, this download sounds Freesound, that you can give a query text, some tag, some duration, your API key, and then the directory that you want to put these sounds into, and then you can specify how many results it should obtain, and the extension of the files. And so what I did was to just write a little example that in fact I could type directly on IPython that basically makes calls to this function. So I import that file, the sound download file. I typed my key here, and these are 3 calls to this function. So I want to get sounds from bassoon, and I want to store them in the TMP directory, and I want to get 20, the top 20 results, and with the restriction that the duration has to be from 0 to 5, and the tag has to be multi-sample. And I do that for bassoon, guitar, and violin, with kind of similar, I guess, this bassoon I could put also from 0 to 3, that would make it easier. Okay, so these are 3 function calls to this function that now we are not going to go through that, but basically this is going to be part of your assignment, and you will get this code, and you will be able then to write something like this to be able to get some sounds. So let's go to the terminal, and again here I have this get sounds file, and if I run it, okay, it obtains, it downloads 20 sounds for every query. This of course depends on the query labels. This might not be possible if the tag is wrong or the query is not correct. We are not going to get so many sounds for that particular query. So if we now go to the file system and we are now in the TMP directory that I created. This is the 3 folders that this little program created. So one to store the sounds of the bassoon, for example. So these are 20 sounds, and in every directory there is the JSON file with the description of the low-level descriptors that I ask for, and the MP3 file. So in fact, the low-level descriptions, if we just open it with gedit, okay, I didn't ask for all of them. So in fact, if we go to sound download again, the only descriptions that have been asked for are these ones: centroid, contrast, dissonance, high frequency content, MFCCs, log attack time, and inharmonicity. So in my JSON file, we have all that. Some of those descriptors, like MFCC, has several values. So this is the information we have for every sound. I also ask for an MP3 file, so we can listen to that to see if that works. So now basically we have all these sounds, all these directories with all the descriptions of the sound, and also sort of a little version of the sound, so we can also listen to them, and we can start doing things with that. So as part of the assignment, we are also distributing another Python code that facilitates doing things with these sounds that we just obtained from the API. So this sound analysis code that you will get with the assignment, we have created different functions that allows us to do display of these features and do some k-means and KNN type of processing, and that you will do in the lab, so no need for going through that now. But let me just at least show you one of these functions. This is a very simple function that what it does, it will display, we give it this input directory, the directory that we want to look for the sounds. This is this TMP directory that I created, and then I can specify the descriptors that I want to show, and then it will plot it in a 2D plot, okay, of all the sounds that I have there. So I have to figure out what I want to plot. So this is all the descriptors that I have obtained. So the number of descriptors was less, but some of these descriptors had a number of different values for these. So for example, the MFCCs. So here we just have the mean of the first 5. Okay, so now I am in this the same directory. I can import the sound analysis file so that I have the functions here. Well, I can better import as for example SA, okay, and now I can call SA dot and I can just get this function, and I will ask for the directory is the TMP directory where I have the sounds in. So this is this directory here, and in terms of the descriptors, I can just put desk input, and I will, for example, use 0, which is the spectral centroid. So here we see that 0 is the spectral centroid, and maybe let's take one of the MFCCs, for example, the first MFCC, and that's number 12. So I can put 12 here, and let's see, that should do something. Okay, so here is the result. I haven't paid much attention to what descriptors to use, but in fact it's already interesting, and we can discuss certain things about this plot. So the sounds I have are guitar sounds, violin sounds, and bassoon sounds. Of course, I have not listened to them, so I don't know exactly what they are like. But well, it's interesting. Bassoon, it's quite clustered, so that means that all the sounds of the bassoon were quite similar. And interestingly enough, the centroid is quite low, which makes sense. Bassoon is a low instrument. And the MFCC, this particular coefficient, number 1, is quite high. The other two sounds, the violin and guitar, are quite mixed. Maybe violin has a little bit higher MFCCs and a little bit lower centroid, but basically the centroid means that the sounds are in the same register. The violin, in terms of yeah, it's a little bit more spread, but that's quite interesting, and we can learn a few things about the sounds and about the features, right? Trying to understand why a particular set of features results in a particular distribution. Of course, we have to listen to the sounds to make sure that we understand what's going on. And well, that's all I wanted to show in terms of the Freesound API. Again, if you want to actually go into more information, you should look at the developers page of Freesound, and that should give you more information. Okay, let's go back to here. And well, for references, again, Freesound, and you need to apply for an API, so for an API key. So this is the URL for applying for the API key, the documentation of the API, and this client library that we are using. So that is a Python wrapper to the API, so we have access to the different resources of Freesound and through the API. And finally, we use two Python software files that in fact come from assignment 9, from this week's assignment. So if you want to reproduce what I just did, you should look at the assignment and get that piece of code. And that's all. So this was a presentation of the Freesound API, very much in tune with what we have been talking about this week, which is to analyze sounds and collections of sounds. Something like an API for Freesound is basic in order to be able to do that in practice. So for programming and exercising this week's type of work, we need such a tool, and this is what we have presented. So hopefully that was useful for you. I'm sure it's not easy, and there is a lot of things that you might have to learn if you want to really go deep into that, but that gave you a basic introduction to it. So thank you very much. That's all, and I hope to see you next class. Bye-bye.